Welcome to Chapter 6, Section 1 for the Momentum and Collision Unit. This is a quick overview of what this unit will look like. Keep in mind the unit test is either on February 5th or February 6th. We will take a quiz at the beginning of the period. We'll do a very quick review of momentum and impulse. And then the in-class work is going to be the assigned questions from practice 6A, 6B, and finally 6C. Your homework assignment is to read chapter 6.2, watch the 6.2 screencast, and take the practice quiz. The learning targets for this unit are: I can compare the momentum of different moving objects. I can compare the momentum of the same moving object with different velocities. I can identify and explain examples of change in momentum of an object, and finally I can solve problems using momentum and momentum impulse theorem formulas. Momentum is anything that has movement, and it depends on the mass and the motion. A normal everyday use of the word momentum is in sporting events. The Packers had momentum in the first half of the playoff game, the Seahawks in the second half of the playoff game. The formula is momentum is mass times velocity. In physics, the symbol for momentum is the lowercase p. The units are kilograms meters per second. Very quick question. Which has more momentum, a supertanker tied to a dock or a raindrop falling? Since the raindrop falling has motion and the supertanker does not, the correct answer would be the raindrop falling. Keep in mind the direction of momentum vector is the same as the direction of the velocity vector. Determining the momentum of a 60 kilogram halfback moving eastward at 9 meters per second, a 1,000 kilogram car moving northward at 20 meters per second, and finally, a 40 kilogram freshman moving southward at 2 meters per second. Correct answer for the first one is 540 kilograms meters per second east. Correct answer for the second one is 20,000 kilograms meters per second northward. And finally, the last answer is 80 kilograms per meter per second southward. Impulse is a change in momentum, and you multiply the force exerted on an object and the time interval over which this force acts. The units are going to be Newton seconds. So delta P is equal to force, or F, times delta T. It can also be the mass times the final velocity minus the initial velocity. There are real-life applications in sports, cars, and even jumping. Quick review. Can a bullet have the same momentum as a truck? To calculate the first part of it, momentum of a 0.03 kilogram bullet traveling at 1,500 meters per second is 45 kilograms meters per second. A 1,500 kilogram truck that travels at 0.03 meters per second, so it's traveling very slowly at 0.11 kilometers per hour, is also 45 kilograms meters per second. So the two of them have identical momentums. A 1,400 kilogram car moving westward with a velocity of 15 meters per second crashes into a utility pole and stops after 0.30 seconds. The magnitude of the force exerted on the car during the collision is 7 times 10 to the 4th newtons to the east. Homework for this unit is reading chapter 6.2, watch the chapter 6.2 screencast, and take the practice quiz. You can also review and get an overview of chapter 6 on YouTube. I've actually posted the website online.